All right, good morning to everybody. Looks like we got 14 people on. So here's a little treat for you for showing up on time. Here's Bambi, my old gal, 14. Hey, Bambi, say hi to everybody. Okay, she's gone. Be a good girl. See you later. All right, so on to math. So today we're dealing with 8.3. Morning, everybody. Good morning. 8.3 is of all the sections that we have to deal with online is probably one of the worst ones to have to deal with. Good morning. Yep. Good morning, Bambi. It's pretty tricky. The good news is there's not a lot from it that's on an exam. Probably just this stuff here. So as always, the important stuff on the board ahead of time. I don't have anything about the roots yet. Once do we have any of those questions? No, nobody had that root question. So I guess maybe that's okay then. But anyways, in 8.3, we're converting from complex to polar. And so a complex number, if you remember, is a plus bi form. Yep, there you go. See, it pays to be here on time. We have our modulus, which is like our Pythagorean theorem. It's our radius. It's all the same stuff that we've been dealing with, same formula all semester, square root of a squared plus b squared. Now to go from complex to polar, we need our value of r, which is just the modulus, so square root of a squared plus b squared, and then tangent of theta. Well, we need theta, and we find that by tangent of theta is b over a. And the key here, just like with all the semester long, is what quadrant do I start in? So based on what quadrant I start in, that's the theta that I need to associate with it. And then when we write this, it's r cosine of theta plus I sine of theta. And you always want to write theta between 0 and 2 pi. That's like the nice way to write it. So if your theta is bigger than 2 pi, reduce it down until it's within 0 to 2 pi. Once we have polar numbers, we can multiply them. And so we just multiply the r values, add the thetas. We can divide them. So we divide the r values, subtract the thetas, and then we can raise them to a power. And we use the Moths Theorem for that. So a polar number to a power is just r to the n, and now we multiply the theta. Good morning. Multiply the theta by our value of n. So any questions on any of that? I know you guys asked me a couple questions. Moths Theorem 1, okay. So again, remember, if you have a question, just type a couple exclamation points. That way I know that you're typing a question and I'll hold up. All right, so I'm going to go ahead and erase this then. If you watch the videos, you should have this in your notes anyhow. We'll refer back to this on some of our problems that we have. Okay, so first one you guys had a question on is number 2. Oh, 2, 4, 5, 6, 7. Okay. Yeah, so just a reminder, if you guys want me to work any problems, make sure that you go onto Canvas. I create that discussion thread with, in this case, like homework 8.3, and then post your question and post the screenshot of it. That way I know what your guys' numbers are, what the problem is ahead of time. So you guys can do that, well, I would say by like 8 a.m. on Tuesdays and Thursdays, because at 8:30 I start my first class and I'm probably not going to be able to get back and look at it. So, all right, let's do number 2 here first. So we have two polar numbers. Z1 is 2 root 3 minus 2i, and Z2 is negative 1 plus I. Yeah, so I can try to go back and look at it again. you know, this is half on you guys. You need to let me know these problems ahead of time. As you guys are working some of these, I'll try to go back and look at some of these others you guys asked about. But I mean, that's the only way, because I can look on WebAssign, but I'm not going to have your numbers. And then to have you try to like tell me what the problems and numbers are through the, if we were in class, it wouldn't be a big deal because I could come and look at your problems and so forth. But over this typing your answers or typing your questions in, it might get a little messy. So I'll try to go back and see if I can figure these guys out. All right, so first off, they want Z1 in polar form, Z2 in polar form, the product, division, and then 1 over Z1. So let me show you how to do the conversion for Z1, and I'll let you guys try Z2, and then we'll go on from there. So for Z1, first thing I need is the radius, so I'll call it R1. So this is the modulus. It's 2 root 3 squared plus -2 squared. So 2 times square root of 3, square root of 3 squared is 3, 2 squared is 4, 4 times 3 is 12, -2 squared is 4, so this is 12 plus 4, which is 16. So our R1 is equal to 4. For our theta, so tangent of theta 1 is b -2 over 2 root 3. So the 2's cancel out. I get -1 over root 3, which we know when we rationalize it becomes -root 3 over 3. So I have 2 possibilities for theta here, and it's dependent on which quadrant I'm in here. So this is what? So our complex plane, our A is like our X value, our B is like the Y value. So A is positive, B is negative. So A is positive, B is negative. So I'm down here in quadrant 4 for this guy. So where in quadrant 4 is tangent of theta equal to -root 3 over 3? That's when theta is equal to 11 pi over 6. So I have R1, I have theta 1. So Z1 in polar form is R, which is 4, cosine of 11 pi over 6, plus I sine 11 pi over 6. So any questions on that one, how to convert from complex to polar? If not, go ahead and try Z2. I'll give you guys a few minutes to try that. Once you finish it, just type done. And what do we got? 24 people. So once the majority of you guys have Z2 converted, then we'll move on to the product, the quotient, and 1 over Z1. Yeah, and if you already have it done, that's fine. Just let me know. That way, like I said, you guys aren't waiting on me to try and get moving here. So what's the other ones? 2, 4, 5, 6, 7, 10. Let's see what 10 is. Yeah, as I said, this is definitely one of the more complicated sections that we have to cover. Certainly doing it in this format, this remote teaching, is not ideal. Again, the good thing is there's not a lot on the exam. So probably my guess as to what will be on the exam is going to be a question like this. So I'll give you guys Z1 and Z2. That's the answer. I'm not sure. So once you have the answer, just type done, Teresa, and then hopefully that's right, but we'll go back through and yeah, that's probably right. Square root of 2. Yeah, I think that's right. And then let me talk a minute as well about the exam. So I talked with the coordinator for 127 this morning about the final exam. And he's not really sure right now what format he's going to go with. Is he going to use Canvas? Is he going to use WebAssign? I think he's leaning towards WebAssign, which I think probably makes pretty good sense in terms of the type of questions that are going to be asked on the final. So if that is the case, your guys' exam 3 will also be a WebAssign exam. So much like your assessments that you do every Sunday night, it'll be very similar to that. It'll just be a semester's worth of equations. And so we're going to look into it a little bit more this afternoon, kind of email each other and touch base. So hopefully by Thursday, we might have a decent idea as far as what the final is going to be. Because what is it, 4/7? Yeah, it's in about a month. So May 15th is your guys' final exam. So just over a month and a week. And so I'll let you guys know that as soon as I know. And then again, that'll kind of lead into your guys' exam 3. I'll do it the same format. So I want you guys to be familiar. You guys, it won't be too bad because you've been doing those assessments. And so I'm writing the final for 126, but not for 127. But I'm assuming, or my hope is that he will send it to all of us ahead of time. And so I'll know exactly what's on it to make sure that you guys are prepared, just as if it was a, paper exam that you're sitting there for 2 hours taking. But yeah, otherwise that's sort of the plan. So I'm not writing it, he's writing it, but he's getting a lot of input from all of us. So I should have a pretty good idea, what's going to be on it. So, all right, so let me get into this problem here. So Z2. So our R2 is going to be square root of 2. So if you guys need me to work this out, let me know. Otherwise, I'll kind of give you what the R's and Thetas will be to save a little bit of time here. So our Theta 2, so this is in which quadrant? A is negative, B is positive. So this is in quadrant 2. So our Theta 2 is going to be 3 pi over 4. So Z2 is root 2 times cosine of 3 pi over 4 plus I sine of 3 pi over 4. So I think as Teresa had, right? Cosine. Yep, exactly. So anybody not get this, have any questions on this? Otherwise, I'm going to erase most of this so we can do the product, the quotient, etc. Let me move these guys up. Z1 is 4 cosine 11 pi over 6. And Z2 is root 2 cosine 3 pi over 4. I sine 3 pi over 4. So we got square root of 2 because our Z2 is negative 1 plus I. So our R is square root of negative 1 squared plus 1 squared. So square root of 1 plus 1, square root of 2. I would say always use parentheses. Because if you don't use parentheses, if you have this, On this case, the square root of 2 is distributed to both pieces. Here, the square root of 2 is only attached to this term and not this term. So these two are not the same. So always use parentheses because it's square root of 2 times this and square root of 2 times that. Because remember, if you want to check your work, do I have this right or not? Just convert it back to a plus bi form. Cosine of 3 pi over 4 is negative square root of 2 over 2. So negative square root of 2 over 2 times square root of 2 becomes negative 1. That's what we have here. Sine of 3 pi over 4 is positive square root of 2 over 2. That times square root of 2 becomes 2 over 2, which is 1, so plus 1i. So if you just have this here, this would be square root of 2 over 2 times square root of 2. Square root of 2 times square root of 2 is 2. 2 over 2 is 1. Negative. So negative 1 plus, and then this is just root 2 over 2i. This is not the same as what you started with. So always use parentheses. Okay, so let me move on here. So first thing they want is z1 times z2. So I'm going to multiply the r's. So 4 times square root of 2, and then add the thetas. So cosine 11 pi over 6 plus 3 pi over 4. And same for sine, 11 pi over 6, 3 pi over 4. And you see, these numbers always have to be the same. If this is 11 pi over 6, that's 11 pi over 6. If that's 3 pi over 4, that has to be 3 pi over 4. If that's the sum, that's the sum. They're never going to be different. So simplify this. We have 4 root 2 cosine. So now we need to add these two together. So we get what? 44 pi plus 18 pi over 24. So same thing over here. 44 pi plus 18 pi over 24. Simplify this again. So 44 plus 18 is 62. We have 62 pi over 24. This is not, we're not done here. So these two numbers are bigger than 2 or 2 pi. So 24 times 2 is 48. So this one is bigger than 2 pi. So if I do 62 pi minus 2 pi, which would be 48 pi, what do we get there? 14? Yeah. So 14 pi over 24. Simplify this, divide them both by 2, is 7 pi over 12. So this guy between 0 and 2 pi is really 7 pi over 12. Your final answer for this part would be 4 root 2 times cosine of 7 pi over 12 plus I sine of 7 pi over 12. So questions on that one? No? All right. So that's for the product, Z1 times Z2. Yeah, don't forget you want your answer to be between 0 and 2 pi. So if it's bigger than 2 pi, just subtract that out. Okay, got a question. Hold on. Yeah, so we want this number that's inside the parentheses with our trig functions to be between 0 and 2 pi. 62 pi is bigger, 62 pi over 24 is bigger than 2 pi because anything over 24, well, 24 doubled is 48. So 48 pi over 24 is equal to 2 pi. So if this answer is bigger than 48 pi over 24, we need to subtract 2 pi out of this. So we have 62 pi over 24 minus 2 pi. So this guy is really 48 pi over 24. Which is 14 pi over 24. Simplify, take 2 out of both, is 7 pi over 12. Make sense? All right, so let's move on here. We got to get through these problems. So next one, Z1 over Z2. So Z1 over Z2 by the formula is R1, 4 over square root of 2. And now we subtract the thetas. So cosine of 11 pi over 6 minus 3 pi over 4. Yep, okay, no problem. So if we want to rationalize this, you probably don't have to, but multiply top and bottom by root 2. We have 4 root 2 over 2. That cancels, so this just becomes 2 root 2. So we have 2 root 2 in the front, cosine, and now subtract these. So it's 44 pi minus 18 pi over 24. So 44 pi minus 18 pi over 24. So we get 2 root 2 cosine. 44 minus 18 is 16. So it's like 16 pi over 24. Divide everything by 4. Divide everything by 8. You get 2 pi over 3. So cosine of 2 pi over 3 plus I sine 2 pi over 3. Okay. So that would be the ratio. Was that right? Did you guys get the same answer? Hopefully that's right. 16. Wait. Yeah. No, 26, right? 26 pi over 24. Hold on, this is wrong. Too early for math here. Yeah, it's 26. So sorry, 26 pi over 24. Divide both by 2, you get 13 and 12. This should be 13 pi over 12. 13 pi over 12. 44 minus 18, 26, not 16. So that should be your answer there. Yeah, yep, 13 pi over 12. Yep. Okay, 13 pi over 12. So any questions on that other than my math error there? All right, so then the last part of this problem is they want 1 over Z1. So we're actually going to use the Moths Theorem here. That's the easiest way for us. If I rewrite this using my exponent rules, 1 over Z1 to the first power, let's use red here. This is the same thing as Z1 to the what? To the minus 1 power. So I'm going to use the Moths Theorem with my n is equal to -1. So we have what? Z1 to the negative 1 is my R 4 to the nth power, negative 1. And then cosine of n, which is negative 1, times theta, 11 pi over 6, plus I sine of negative 1 times 11 pi over 6. So the Moths theorem is when we have a polar number to an exponent, then we have the formula that we can use. And in this case, our exponent is just a negative 1. So simplify this. 4 to the negative 1 is like, get rid of the negative exponent, 1/4. And then simplify this. We have negative 1 here. So this guy becomes what? Negative 11 pi over 6. So cosine of negative 11 pi over 6. Cosine is what? Cosine is an even function. When we have an even function, what happens to the negative sign? It goes away. So this piece, cosine of negative 11 pi over 6, is the same as cosine of 11 pi over 6. Same idea here. This is negative 11 pi over 6, but sine is an odd function. What happens with odd functions? The negative sign comes in front. So minus I sine of 11 pi over 6. So that would be your answer for 1 over Z1. Again, using de Moths theorem, it's a little bit easier. We just have that negative 1, then do your even odd functions, and that. All right, so let's move on here. Let's look at number 6, and then hopefully from number 6, you guys can get number 5. Again, just interest of time here, try to get through as many of these as we can. So number 6 is another de Moths theorem. We have 1 minus I to the 7th power. So by de Moths theorem, 7 is my n. I still need the r, I still need theta. So r is what? It's the square root of 1 squared plus negative 1 squared. So again, this is our square root of 2. And tangent of theta is negative 1 over 1, which is negative 1. Which quadrant is this in? A is positive, B is negative. So this guy is in quadrant 4. So where in quadrant 4 is tangent equal to negative 1? That's when theta is 7 pi over 4. So we have our theta, we have our r, and we have our n. So by de Moths theorem, we have what? Z to the 7th power is r square root of 2 to the 7th power. Cosine of n, which is 7, times theta, 7 pi over 4, and same thing for sine. So any questions on that, how we get those values and then plugging it into the formula? Okay, so simplify this. So this guy here, square root of 2 to the 7th power. So this is what? It's root 2 times root 2 7 times. So square root of 2 times square root of 2 is 2. And 2 again. And 2 again with a 2 left over. So 2 times 2 is 4, times 2 is 8. So this guy here, root 2 to the 7th power, is really 8 times square root of 2. Let me do this. 8 root 2. And then simplify inside of here. So this is cosine 7 times 7 pi over 4 is 49 pi over 4. So again, we don't want these values of theta to be bigger than 2 pi. So simplify this down. 49 divided by 4 is 12. That's 48, so I have 1 left over. So 12 pi puts me back at the start. It's an even number, plus pi over 4. So this guy is really equivalent to just pi over 4. So we get to this point here, 8 root 2 times cosine of pi over 4 plus I sine of pi over 4. Now, just like on exam 2, just like WebAssign has been doing all semester, it tells you how they want the answer formatted. And for this one, it says write your answer in A plus BI form. So I need to convert both of these with my unit circle and then multiply it by 8 root 2. So cosine of pi over 4 is what? Square root of 2 over 2. So 8 root 2 times square root of 2 over 2 is 8 times 2. 8 times 2. Yeah. 8 times 2, yep, all over 2. So the 2's cancel out. So when I distribute 8 root 2 times cosine of pi over 4, this is just equal to 8. I'm going to get the same thing when I do this here as well. So 8i. So your final answer is 8 plus 8i. You take cosine of pi over 4, that's square root of 2 over 2. Multiply 8 root 2 times that. The 2's cancel out. I'm just left with 8. Your answer is 8 plus 8i. Questions on that one? All right. What time is it here? So 45 minutes. Was that one? So let's go to, so 5 you should be able to do now. It's the same as this guy, just a couple different numbers. Actually, I think the numbers work out to be easier, maybe. Let's do number 4. So number 4 says find the square roots of 4 root 3 plus 4i. So actually, that's the question. Let me talk about the roots, how we figure these out. So when we're finding roots, we have the formula omega k is r to the 1 over n, where n is the number of roots. So if I have a complex number with r and theta and n roots, then the formula is r to the 1 over n cosine of theta plus 2 pi k over n plus I sine of theta plus 2 pi k over n. And then k is 0, 1, 2, etc. up to n minus 1. So if I had 5 roots that I was looking for, I would have k is 0, 1, 2, 3, and 4. So n minus 1 is 4. So I still have the 5 roots, but k starts at 0. So we're going to figure out r, figure out theta, square roots. So that's what? That means 2 roots. So square root is 2, cube root is 3, and then the rest are as it is. So find the 4 roots of, find the 5 roots of. So that's a little bit easier. But when we have square roots and cube roots, Square roots means we have 2. Cube root means we have 3. So this is the formula we're going to be using. So we know that our n is equal to 2 because of square roots. Now I need my r. So r is the square root of 4 root 3 squared plus 4 squared. So 4 squared is 16 times 3, that's 48. 4 squared is 16. Add these together is 64, so 8. So for this instance, our r is equal to 8. And then to figure out theta, so tangent of theta is b over a, so 4 over 4 root 3. That cancels out to be 1 over root 3, rationalized is square root of 3 over 3. So which quadrant are we in? A is positive, B is positive, so this is in quadrant 1. So where in quadrant 1 is tangent of theta equal to square root of 3 over 3? That's when theta is equal to pi over 6. So we have n is 2, r is 8, theta is pi over 6. So any questions on that before I move on to the formula part of it? All right, so we set up our formula. Omega k is r, which is 8, to the 1 over n, so 1/2 power. And anything to the 1/2 power is what? Square root. So square root of 8. And then our formula is cosine of theta, pi over 6, plus 2 pi k over n, which is 2. And again, same thing for sine. Pi over 6 plus 2 pi k over 2. So any questions with that? Plugging the information into the formula. All right, so let's figure these out now. So for when k is 0, so omega 0, our first root is square root of 8. When k is 0, this piece is gone. So it's pi over 6 divided by 2. Pi over 6 divided by 2 is like pi over 6 times 1/2. So this just becomes cosine of pi over 12. And then same answer for the sine piece. Questions on that before we move on? All right, and then the second one, omega 1. And again, we're only going up to k is equal to 1 because it's the number of roots n minus 1. So it's still square root of 8. But now when k is 1, this becomes pi over 6 plus 2 pi. So pi over 6 plus 2 pi is pi over 6 plus 12 pi over 6, which is 13 pi over 6. So it's cosine of 13 pi over 6 divided by 2. So this ends up becoming cosine of 13 pi over 12. And again, I'm going to have the same value for the sine part. So your answer is our root 8 cosine of pi over 12 plus I sine of pi over 12. And then omega 1 root 8 cosine of 13 pi over 12 plus I sine of 13 pi over 12. Then it asks you to graph it as well. So really all you're worried about is where's my thetas. So pi over 12, that's barely into quadrant 1. And 13 pi over 12, that's a little bit more than 1 pi, so it's barely into quadrant 3. So it's going to be those 2 points there. You want to pick out the graph that has a point barely into quadrant 1 and barely into quadrant 3. So Questions on this guy? All right. So then let's do number 7. So 7 is tricky. It's actually ends up being an easier problem than this because the numbers are a lot easier to work with, but it's tricky because of the way that it's worded. So let me get the exact wording here for you guys. Yeah. So it says solve the equation. Let's see here. So solve the equation. Z to the 4th plus 1 is equal to 0. So this means what? So if I move the 1 over, so subtract 1 from both sides, Z to the 4th is equal to -1. So if I had a problem like Z to the 4th is equal to 16. Well, what do? I take the 4th root of both sides. So similar idea here, but this is really a complex number. This is -1 because anything to the 4th power, is that going to give us a negative number? Only if it's a complex number. So this thing is really like Z to the 4th is -1 plus 0i. And so I want what? I want the 4 roots of this guy. So a better way, if again, the way the problem's worded is tricky. Really, all this is saying is find the 4 roots of -1 plus 0i. So go ahead and try this one. So we know n is 4. Find our value for r, find our value for theta, and then use our root formula that we just used. I'm going to make this the attendance problem. So again, in your ticket out the door notebook, if you can put this problem in there as well, that way at the end of the semester, when I'm grading your ticket out the door notebooks for today's class 4-7, this would be the attendance problem that tells me that you watched the videos, you had answered the questions that you had, things like that. So put this in your ticket out the door notebook with attendance written by it. So go ahead and try this. When you get done, go ahead and just let me know. Just type done if you have questions. Ask me questions as well. Otherwise, once everybody is done, then we'll work through it. And as I said, this one, so they want the answers in A plus BI form. So it doesn't say it in the problem. Again, this is a really poorly written problem, but that's what they want is the A plus BI form. So go ahead and give this a try. So Eric, do you still have a question on number 10? Or now that we kind of talked about the graph, A is like our X's and B is like the Y, how to graph those, or is that still an issue? So again, once you guys get done, just type done. Once I see most of you have it, then we'll work it on the board here. Number 10. Yeah, and that could be true, Jay. Yeah, if you find like one point that has the only one, then the rest don't even really matter. So, and you guys won't have anything like that. Obviously, I can't ask you to graph points. So, let me, before I forget as well. So for Thursday, we're going to be doing 8-4. Okay, good. So a lot of you are wrapping up. Okay. So for Thursday, we'll be doing 8-4, which is parametric equations. And you're going to be converting from a parametric equation to a rectangular equation. If there's no trig functions, it's pretty easy to do. The issue comes in once you're faced with trig functions. So what you're going to want to do, if you just want to remember this as you try the homework, and I'm sure we'll do them on video on Thursday anyhow, but if you want to try to give it a shot yourself, what you're going to do is you want to see if there's any equation that has the trig functions that you're given. And if you can use that equation to do a substitution, for example, if one of your parametrics is x equals sine of t, and the other one is y equals cosine of t, then what equation do we know that has sine and cosine in it? It's our Holy Grail. So you would use the Holy Grail formula and try to do substitution and convert that equation to x's and y's and numbers instead. So keep that in mind. Again, if you don't get it, that's fine. We'll work them on Thursday anyhow. But if you want to see if you can do it on your own, that's the little trick to kind of keep a heads up for. So yeah, this chapter is kind of funny. we go from like all this trig math. Yeah, this chapter is challenging because it's like totally different material. We went from all this, trigonometry, sine, cosine, tangent, to these polar graphs and polar equations and parametric equations. It kind of doesn't feel like it ties in a lot with what we've been doing. It has a little bit, as you can see, and everything is sine and cosine here, but it does get a little bit tricky. So what I would say is don't worry too much about this chapter. Again, on the test, I will tell you guys exactly what it is you're going to need to know. And if at that point you need to go back and refresh your memory, then you can maybe rewatch videos, because the question everybody always asks in a math class is what? When am I ever going to use this? And I'm going to be honest with you, unless you're going on to like higher level math classes, you're not really going to use much of any of this at all. So I wouldn't stress out and I wouldn't waste a lot of your time like trying to master all this material, because you're just not going to have to. For the exam, it's usually stuff that's pretty straightforward. Again, basically like question number 2. So from this section, if you can do question number 2, that should be good enough for what you're going to need on the exam. So this be used. Let's see, physics, potentially physics. Yeah, it's really more though, like I said, like if you're a math major or something, you can be, oh shoot, yes, let me ask. I have to call IT anyways. They called me back about an issue I was having. So I'll let me write a note down to ask them about that. View test 2. Yeah, I forgot about that, sorry. But yeah, really more is like math. If you're a math major, maybe a computer science major, you might use some of this stuff, but aside from that, yeah. And again, I'm not going to make you waste any time on learning how to do these roots, because you're just not going to really need it anywhere. So yeah, so engineering, yeah, so physics for pre-med, probably not too much. Physics for engineering, possibly. But yeah, that's about it. It's really more of like higher level math than anything. All right, so let's try this one. So our R that you should get is equal to 1. And the theta you should end up with, where if I plot this guy, where does he end up? 1 to the left, 0 up or down, which is right here. So that's what? Theta is equal to pi. So did anybody not get this? R is 1, theta is pi. Otherwise, I'll move on to the formula part of it. All right, so our formula, omega k, is 1, the fourth root of 1. Any root of 1 is just 1. So really all we're dealing with is cosine of pi plus 2 pi k over how many roots? 4. And plus I sine of pi plus 2 pi k over 4. So now I have 0, 1, 2, and 3. So when k is 0, again, this piece goes away. So it's just cosine of pi over 4 plus I sine of pi over 4, which is what? Cosine of pi over 4 is root 2 over 2. Sine of pi over 4 is also root 2 over 2. So for when k is 0, your answer in a plus bi form is root 2 over 2 plus root 2 over 2i. How about when k is 1? So when k is 1, this becomes 2 pi. So pi plus 2 pi is 3 pi. So 3 pi over 4. How about when k is 2? 2 times 2 is 4, so 4 pi plus 1 pi is 5 pi over 4. I assume you can see the pattern now. It's just all the pi over 4 values. The last one, k is 3, is going to be cosine of 7 pi over 4 plus I sine of 7 pi over 4. And again, then just figure out root 2 over 2 or negative root 2 over 2, and that'll give you all your A plus BI answers. So any questions on that? All right, so let me give you guys your ticket out the door problem then. This way we got plenty of time to go through it if you guys have questions. And again, that's your attendance problem, so please just put that in your ticket out the door notebook. All right, so for your ticket out the door today, it's just one problem. It's if Z1 is equal to negative 1 plus I, Z2 is 1 minus root 3I, find the following. So write Z1 in polar form, write Z2 in polar form, and lastly, find Z1 times Z2. And just leave your answer in polar form for the third one. So again, when you guys get done, go ahead and type done after a few of you have it. I'll give you guys the answer. If you have questions, again, feel free to ask questions as we go. So Eric, I didn't hear back. Were you okay on number 10 now that we just know A and B is sort of like X and Y? Okay. So again, once you guys get done, just let me know you're done. After a few you have it, I'll put the answer up on the board so you don't have to wait on me before you log off. All right. So a few of you are finishing up, so let me go ahead and put the answers up. Again, if you guys don't have the answers yet, that's fine. Just keep working. If you do have questions, go ahead and ask those as well. So the first one, so for A, Z1 in polar form is square root of 2 times cosine of 3 pi over 4 plus I sine 3 pi over 4. Z2 is 2 cosine 5 pi over 3 plus I sine of 5 pi over 3. And Z1 times Z2 should end up, after you're done simplifying, 2 root 2 times cosine of 5 pi over 12 plus I sine of 5 pi over 12. So again, if you're working still, that's fine. Keep working. I'm not logging you off yet. We still got time. If something doesn't make sense, you have a question on it, that's fine too. Otherwise, if you're done and you got those answers, then have a good day. See you guys Thursday again, especially because there's some graphing that's involved on Thursday. Yeah, that's fine, Dominique. Go ahead. Because there's graphing on Thursday, make sure that you post the questions that you have an issue with so that I can look at the graphs and so forth. How do you know from... so which quadrant is Z1 in? So our A is negative, that moves it to the left. B is positive, that moves it right. So Z1 is in quadrant 2. So we want to choose the pi, the theta that's in quadrant 2. Same thing for 2 pi over 3 or 5 pi over 3. That's in quadrant 4, so we want that one. So to Dominique's question, no, there's no quiz for 8.4. There's not really like basic concept stuff. They're all just problems. So if you didn't know how to do it, I want you to be able to ask for the video class. So there's no quiz for 8.4. So thanks for reminding me of that. Yeah, I forgot about that. So no quiz for 8.4. But again, otherwise, if you guys are done, if you got those answers, you don't have questions, you're free to log off. I'm not going to intentionally give you any secret information. So I've told you guys everything I remember to this point. And otherwise, we'll just workout C. Okay. So did you get part A and part B, Lisa? Were you able to do those conversions? So that's the big thing. If you can do the conversions, then the rest is formula stuff. So for the product, we're multiplying the r's, so 2 times root 2, and then we're adding the thetas. So cosine 3 pi over 4 plus 5 pi over 3. Okay. So then when we simplify this, so we have 2 root 2 cosine, this becomes 9 plus 20, so 29 pi over 12. And plus I sine 29 pi over 12. So we have to add these two fractions, add these two guys together. So that gives us 29 pi over 12. Oh, okay. So I'll keep working it in case somebody else had a question. So 12 times 2 is 24. So this is bigger than 2 pi. I need to simplify it down. If I take 24 out of this, then I'm left with the 5 pi. After this step, that gets us to our final answer. So, any other questions you guys have? So if nobody else has any questions, I guess I will end the video stream here. If you do have questions, hit the exclamation point real quick. Otherwise, I'm going to shut it down here. This video, yeah, it should basically in a minute or two post to YouTube, so you can always go back and watch any of it. If you guys showed up late, Bambi made an appearance at the start of the video. So if you want to see Bambi, she's at the start. Otherwise, I will see you guys on Thursday. Yep. Okay. So, all right. You guys have a good day, and we'll see you soon. Be safe.